So this screencast is talking about how we use gas laws in stoichiometry situations. So if you're given a stoichiometry problem, sometimes instead of starting with grams and going straight to moles, sometimes you'll have to apply gas laws to the situation. It may be that you apply the gas law information to one of the reactants or possibly one of the products, depends on what they are given. But the keys to this is they will talk about a chemical reaction and they'll give you pressure, volume, and temperature information, and you might have to calculate moles. Or they'll ask about one of those things for one of the products. So, for example, they might ask about the volume of a product or the pressure of a product if you know some of the other characteristics like the temperature or so. Just look at the stoichiometry problem and figure out where you're starting, where you're ending, and what kind of information about the gas that they are giving to you. Watch out for your units. So look at what the units are given to you in and what kind of unit you're trying to go to, and that'll probably give you a hint as to if you have to apply a gas law. So here's an example problem of using gas law stoichiometry. And you'll see right away that they start giving us gas kind of information. So it says in a rigid 1.7 liter container, oh look, there's a volume. So we have a volume. The container contains 52 grams of methane and excess oxygen gas, and is at 27 degrees Celsius. So there's a temperature for us. After the completion of the combustion of the methane, what is the partial pressure of the water vapor produced? So what they gave us was some information about one of the reactants. We know about methane, and we knew we had 52 grams of methane. And they're asking us about the partial pressure of the water vapor, which is one of your products. So this, because they're asking about pressure, you know that this is a gas law that's being applied to the stoichiometry situation. So just like all stoichiometry problems, we need to start with a balanced equation. So we're going to start with methane, CH4, is going to combust in the presence of oxygen, and we are going to produce carbon dioxide and water. Those are going to be our products. We got to make sure we balance our equation. So we're going to put a 2 here and a 2 in front of the oxygen. And now we should have a balanced chemical equation. So just to orient ourselves, we're starting with 52 grams of the methane. And they're asking me about the pressure of the hydrogen. So I'm going to have to find out first the moles of the methane, and then get the moles of the water, and then given the conditions, we'll be able to calculate the pressure of the water. So let's start the stoichiometry problem. So we're going to start with 52 grams of methane, and first thing we're going to do is convert that into moles, and there are 16.05 grams in a mole. So we have, calculate that out, that gets us 3.24 moles of methane. And then using stoichiometry, for every 1 mole of methane, you produce 2 moles of water. And that means we are going to produce 6.48 moles of water. All of that's just from the stoichiometry. Now the question is, well, what's the pressure of that water? Well, what are the 3 things we know? We know the moles of the water, we know the volume of the container, we know the temperature, and therefore we're going to be able to calculate the pressure. So we're just going to say pressure is equal to the moles times our gas constant, 0.0821 liters ATM, moles Kelvin, times our temperature, which was 27 degrees Celsius, which we need to change that to Kelvin, so that's 300 Kelvin, all divided by our volume, which was 1.7 liters. And notice what happens to our units. Moles cancel, liters cancel, kelvins cancel, and we're left with ATMs. And now we just calculate that out, and so we find that the pressure is equal to 93.9 ATM.